Okay, we're going to finish up the final part of Grading Period 4 Benchmark Study Guide. We're going to begin with number 23, which is a rectangle, and it says find the perimeter. Well, you have to know that perimeter is the distance around the outside of the rectangle. So that means I have to add all the sides together. Well, do I know the lengths of all the sides? Actually, I do. Because if this is x squared plus 2x minus 5, so is this. And if this is 3x squared minus 3x plus 2, so is this. So I have the lengths of all four sides. So if I add 3x squared minus 3x plus 2 and x squared plus 2x minus 5 and 3x squared minus 3x plus 2 and x squared plus 2x minus 5, I should get the perimeter of this rectangle. It's a lot of terms and a lot of polynomials. But we can do this. If I distribute a 1 to all of these, you know what's going to happen? Absolutely nothing. They're all going to keep their original value. They're not going to change their value one bit. If I distribute a positive 1 here and a positive 1 here and here and here. So let's check this out. I got a 3x squared here. I got an x squared here, a 3x squared here, and an x squared here. So I have 3, 6, 7, 8 x squareds. Okay, I have a negative 3x and a positive 2x and a negative 3x and a positive 2x. And if I combine those, let's combine our positive, we got 4 positive x's, and we got 3 and 3 is 6 negative x's. If I combine those, we have more negatives than positives. We're going to have 2 extra negative x's. And lastly, if I combine this positive 2, negative 5, positive 2, and negative 5, if I put these two negative 5's together, that's negative 10. And if I put my two positive 2's together, that's positive 4. If I have 10 negatives and 4 positives, I have more negatives than positives. I have 6 negatives, and I believe that's the perimeter of that rectangle. Could we have done that another way? Let's look at this again. We added up all the sides, right? But wait a minute. Don't we have 2 sides that are this length and 2 sides that are this length? So if I double this and double this and add them together, shouldn't that give me the perimeter? So if I have 2 sides that have a length of x squared plus 2x minus 5, and I add that to 2 more sides that have a length of 3x squared minus 3x plus 2, I'm thinking that should give me 1, 2, 3, 4 sides. 2 this length, 2 this length, add it all together, that should give me my perimeter. So this would be distributing 2x squared plus 4x minus 10, sorry, and plus 6x squared minus 6x plus 4. Check it out. This and this is 8x squared. 4 positive x's and 6 negative x's is negative 2x. And 10 negatives and 4 positives is negative 6. I believe that's what I got the first time. Check it out, baby. Exactly the same. Now, if this confused you, do it this way. Doesn't matter. They both work. Adding up all sides or doubling one side and doubling the other side and then adding them together, they both work. Love it. Love it, love it, love it. Okay, number 24. We're dividing every stinking term in the numerator by 5n squared. So we're going to rewrite it like this. 15n to the 5th divided by 5n squared plus 25n to the 3rd divided by 5n squared minus 10n squared divided by 5n squared. Now, we're going to take each of these separately and we're going to simplify them. So, 15 can be written 3 times 5, and n to the 5th is n times itself 5 times. And in the denominator, I have a 5 and I have n squared. Cancel, cancel. So that gives me 3. Oh, cancel one more. 3 n to the 3rd in my numerator. And I'm going to add 25 is 5 times 5. And then I got 3 n's over 5 n squared is n times n. Cancel, cancel, cancel. And I'm left with 5n. Be careful. Now we're going to subtract 10n squared over 5n squared. Well, I already know my n squareds are going to cancel out. I got 2 at the top and 2 at the bottom. And isn't 10 over 5? 10 divided by 5 is 2, isn't it? Ta-da! Nice. All right, let's look at number 25. We're adding all these polynomials. When we add, we just distribute a positive 1 to every stinking term. And when we distribute a positive 1, nothing changes its value. So I have 7x to the 4th plus 3x squared minus 4x plus x squared minus 5 to 5x. Highest exponent, no buddies to hang with. Next highest exponent, no other x squareds to hang with. I have a negative 4x and a negative 5x. That's negative 9x when I put all those negatives together. But then I also have one positive x. If I have 9 negatives and 1 positive, I have a lot more negatives. How many negatives do I have left over? 8. And there's my answer. This is actually fun, right? This is tricky and it's worded differently, so think about what you're seeing here. We're going to subtract this polynomial from this polynomial. They each have 4 terms, and we're going to take this one away from this one. So if we're going to take this one away from something, I guess we better start with the other polynomial. We better begin with this one. So we can take this one away. Subtract it, take it away. 2x to the 3rd minus 7x squared plus 5x plus 4. But here's the deal. If I have to subtract all of this, that means I have to subtract every stinking term. So I have to put it in parentheses, so I'm sure to distribute that negative to every stinking term inside my parentheses. And we can think of that to make it easier as a negative 1. And when I distribute a negative 1, every term inside the parentheses changes its sign. Now I could put this in parentheses, but I'm just going to distribute a positive 1 and nothing's going to change. So I still have 5x to the 3rd minus 2x squared minus x minus 3. Now I'm going to subtract all these, so they're all going to change. This is negative 2x to the 3rd. This negative 7x squared becomes positive 7x squared. Positive 5x becomes negative 5x, and positive 4 becomes negative 4. Now I'm going to combine like terms as much as I can.